In this presentation, we are going to start the discussion of the chapter 3, which is energy. And today we are going to define energy, work, and power. Let's start with energy. Energy is the capacity for doing work. Also, we can define energy as a quantity that must be transferred to an object in order to perform work. And also can be defined the quantity that must be transferred to heat an object. The energy, there are different forms of energy. The energy can be mechanical, can be chemical, can be electromagnetic, nuclear, or solar energy. In the mechanical energy, we can find the kinetic energy, which is related to the motion, and potential energy, which is related to the position of the object. Chemical energy, in which the chemical reactions are involved. Here we have one example. The electromagnetic energy, in which the electric and magnetic waves are involved. The nuclear energy is the energy due to the reactions in the nucleus of the atom. Is called also atomic energy. And the solar energy, which is related to heat. Yes, this is related to heat. As we saw, there are different kind of energy, different types of energy. That the energy can transform from one form to another form of energy. Here we had few examples how chemical energy can be transformed into the mechanical energy, or radiant energy can be transformed into the chemical energy through the photosynthesis process. Also, chemical energy can be transformed into the mechanical energy, as in this case into the exactly kinetic energy. Or electrical energy can be transformed into the thermal energy. But this is few of examples. Here we have more complete chart in which you can see all the transformations are possible. Yes, for example, we already discussed that radiant energy can convert into the chemical energy to the photosynthesis process, but also chemical energy can be transformed into the radiant energy through the oxidation process. Also, here the mechanical energy can be transformed into the electrical energy through the electric generator, but electric energy can be transformed into the mechanical energy through the electric motor. As for example, the blender or the washing machines are examples of the transformation from electrical energy to mechanical energy. And we can see there are all possibilities is one energy can be transformed into another energy. And what happens is the energy always will be transformed from one energy to another energy. We cannot create or destroy energy. Always the energy will be transformed from one form to another form. In the way the total amount of energy in the universe will be always the same, never change. Also, energy is in physics, we can use the energy approach to solve problems that can be more complicated to solve using, for example, the Newton's law. Also, we can see now, we will see how the work will provide a link between force and energy. And we already know the force definition. Now we start discussing energy, and now the next thing we are going to discuss is work. And we will see how the work provides the connection between the force and energy. How the work is defined in physics it's different the idea we had the work. For us, the work is a physical effort, is associated with a physical effort, but sometimes even if you are doing some physical effort, you are not doing work from the physics point of view. And this is what we are going to learn in the next slides, how we can define work. First thing is we can define work as the product of the force multiplied by the distance. But force and distance must be parallel, must be in the same direction. Then the work is the product of the force times the distance in which the force was acting on the object. But in the only cases we can calculate the work is in which the force and the distance, they are parallel. Then remember this equation is the product of the force times distance apply only if the force is parallel to the distance. Other words is the force is in the same direction of the distance. Another thing is I want to mention is the work is an scalar quantity, means there is no direction associated with that quantity. It's just number and unit. Then for example, if we want to calculate the work we had to do to lift a book from the floor to this shelf, then what we had to do is we need to know what force we need to apply, and we need to measure the distance. And if we multiply the force we apply to lift the book and times the distance we lift, in which in the distance we move the book, then we can calculate the work was done. Now let's define the units of work. And let's start with the SI system. Then we know now we define the work as the product of force multiplied by the distance. Then the units for force are newtons, and the units for distance is meters. And newtons times meter, these are the units for work, newtons times meter. And this unit has a special name, which is joule. Then we have newtons times meter, this corresponds to joules. And we can abbreviate this unit with the J. Also, we can define joules as kilograms meter square per second square. And let's try to explain why we can write joules like that. Then first, we had force, yes, because we had force here, force equals to mass times acceleration. And we know the units for force is Newton. And let's define force, the units for mass is kilograms, for acceleration is meters per second square. And this is why we define as 1 Newton. Now, work. Newtons times meter. As this is we had here, newtons times meter. The newtons, but 1 Newton is kilograms meter per second square times meter. As Newton is just kilograms meters per second square, and then we need to multiply by meter. And this part is this part, this is this one. And if we multiply this together, we have kilograms, meters times meter will be meter squared over second squared. And we know the units for work is joules. This is joules. This is why here we can define that 1 joule equals to 1 kilograms meter squared per second square. This is another way we can define also joules. That is equivalent to newtons times meter. In the English system, then we had work equals to force multiplied by the distance, but the units for force in English system is pounds force. Yes, and we mentioned before in your book they will use just this symbol for pound force. Yes, but the correct symbol should be this one. Okay, then in your book, if you have pounds, you know this corresponds to pounds force, and then multiply by the feet. Then in some books appear like this one, like pounds force multiplied by the feet, or feet multiplied by pounds force. Then either way is correct. Then the units for work in SI systems, is joules, and the units for work in the English system is feet multiplied by pounds force. There is no special names for this name for the unit in English system. Now let's see in what cases we are doing physical effort, but by the work definition in physics we are not doing any work. Yes, according to the physics definition. For example, if you are holding some object, yes, but you are not moving, you are doing some physical effort, but you are not doing work. Because remember, work is force multiplied by the distance, but if the distance equals to 0, then work should be 0. Yes, and in this case, if you are not moving, even if you are doing some physical effort, you are not doing work from the physics point of view. Remember the other case in this equation work, this equation in which we can apply this equation is if the force and the distance they are parallel. And what happens if is the force and the distance they are perpendicular? Then in that case also we are not doing the work is 0. Yes, there is no any work done if the force and the distance they are perpendicular, like in this example. And in these two cases, the work equals 0. If the distance equals 0, and if the force and the distance they are perpendicular. Then let's see, here there are some examples. Then let's see in what cases, why in some cases, even if you are doing physical effort, you are not doing work. For example, when we push an object, then this is the direction of the force, this is the direction of the motion, then both in the same direction, then we are doing work. Yes, but what happens if you are carrying a backpack? Yes, like in this case, and you are doing work in this direction, but you are moving in this direction, then force and distance they are perpendicular, then no work. Yes, you are not doing work. In the third case, if you lift an object off from on the floor, if you are lift an object from the floor, then what happens is the force and the distance they are in the same direction. Then the answer is yes, you are doing work. If you are carrying a bag, yes, like in the example in the picture we had here, then you are doing work in the vertical direction, but you are moving in horizontal direction, then force and distance they are perpendicular, then you are not doing work from the physics point of view. Now, when we say we calculate the work force multiplied by the distance, the force can be any force. Yes, can be any. For example, is the force against of the inertia. Yes, is how much force you need to apply to start moving this car. Then is the work against the inertia. Is the work you apply when you lift an object. Yes. Then in this case you are working against the gravity. When you push something, then you are working against you are applying force against the friction. Then in order to move the object, you have to overcome the friction. In order to lift the box, in this case, you have to overcome the gravity. Also, is another force is the force you need to apply to deform, for example, this spring. Then that force can be any kind of force. Yes, when we just remember the force and the distance must be parallel. Yes, it must be in the same direction. And now let's try to solve this problem. And we want to know how much work is needed to lift a 5 kilograms backpack to a shelf 1 meter above the floor. Then the one we know is the mass of this object is 5.0 kilograms. The distance equals to 1.0 meters. Then we need to calculate the work. Then what we can see here is the distance is applying in this case, and the distance and the force is applying in this case, they are parallel, they are in the same direction. Then we can calculate the work. And the work, how we define work? Work equal to force multiplied by the distance. And we know the distance, but we don't know the force. Then now we need to think is what kind of force we need to apply. And we need to apply the force that overcome the gravity. Yes, and the force we need to apply should be equal to the force, the gravity force is acting on the object. And in this case, the force equals to the weight. Remember weight? Then the force, remember we define the wave is mass times the acceleration of gravity. Then in this case, we can calculate the force equals to the mass times the acceleration of gravity, because the force we need to overcome is the gravity force. And once we know the force, then we can calculate the work. And all the units are in SI system. We don't have problem with that. Then now let's calculate the work. The force. Force equals to mass will be 5.0 kilograms. G value we know is 9.8 meters per second square. It's very important to write the units, because in this way you know if you are doing the calculations correctly. Then if we multiply these two, will be 49 kilograms meters per second square. And we know this one is newtons. Yes, we know this corresponds to newtons. Then now we know the force, we know the distance, then we can calculate the work. Work, force multiplied by the distance, then work equals to 49 newtons times 1.0 meters. Then work equals to two significant digits, newtons times meter, and we know this corresponds to joules. And in this case, the work was done by that person to lift that box is 49 joules. And if the mass of an object is 5 kilograms, to lift that object 1 meter, we need to apply on the object for 49 joules of work, as this is the answer. Then let's now define the power. Power is the rate at which the work is done, or is the work per unit time. It's how fast you can do some work, or how fast some machine is doing some work. And this is why the power is work over time. And if we use an equation, this capital P will be for power, W will be for work, and T will be for time. And if we want to calculate of some machine or for some person or something, then we need to know the work and the time. For example, if we want to calculate the power level of this person to move from this point to this point, yes, to move from here to here, and we need to know the work is done by that person and the time. Then let's see now the work. And we want to calculate the power. Then what is the work he need to do? Is force multiplied by the distance. But the force, then the force he need to do in that case will be against the gravity. Then this is why force will be mass times g. It's like weight, yes? He has to overcome the gravity force. And in the distance will be the height, yes? And this is why work is force will be mass times g multiplied by h. Then if you sometimes will be mass times g multiplied by the v is the same as mass times g multiplied by the h. Just the height is just a distance, yes, it's the same thing. Then now we can say the power will be mass times g divided by the time. And in this particular case, you can see the power equals to mass is the mass of the person. The g value is the acceleration of gravity. H is the height, which is the same as distance, yes, and divided by t. These are basically constant values in these cases. The mass of the person is basically constant. The g value is the acceleration of gravity, which is a constant, and height is in this case is constant value, yes. Then really the power, the level power of this person depend on the time, yes, how much time takes for him to move from this point to this point. But what happens if he takes less time, the power will be increased. Yes, less time, the power, more power. But if he takes more time, the power will be decreased. Yes, more time, the power will be decreased. And we can see this one also if we apply the line test. Yes, we see power and time, they are inversely proportional. More time, less power. Less time, more power. Then we can see power and time, they are inversely proportional. Now let's see the units for power. Then the units for power, first remember we need to start from the equation. the equation for power is work divided by the time, or how much work is done per unit time. And we need to know the units for work. But the units for work we know are, in this case, the units for work in SI system is joules. Yes, and here I just review again, is newtons times meter, but newtons times meters is joule, and we just use J to abbreviate the unit for work, then it's joules. And we know in SI system the units for time is seconds. Then units for work, joules, units for time, seconds, and this unit has a special name, which is watt. Yes, and the symbol is the capital W. But because we had many, we had weight also, we use W. We had work also, the symbol for work is W. And sometimes I prefer to write watt, yes, to avoid any confusion. Then, but you can use also the letter W to indicate watt, yes, that unit. In the English system, then we need again the units for work divided by units of distance. Then in the English system, the unit for work is feet, pounds, force. Yes, this is the units for work. And the units for time is seconds. Then just we divide this feet, pounds, force divided by the unit time, which is seconds. There is no special name for this unit in the English system. Another unit of power is the horsepower. And the reason this unit appeared was because the first engines, when the first engines was invented, there was needed to describe in which rate this engine could do work. Then at this time, people were familiar with using horses to do their work. Then James Watt, who was the scientist that invented the steam engines, he compared the work done by these engines by the work done by the horses, and this is how he defined that one horsepower equals to 550 feet pounds force per second, or 1 horsepower equals to 746 watts. Then this is the conversion factors we can use to convert horsepower to English system of power, or horsepower units to power units in SI system. Also, sometimes when we had large values of power, then we can use prefixes. Then this is why if we had, for example, 1 kilowatt, then we can write this one like that, or we can just write 1000 watts. Yes, but we can write this one 1000 watts, but like 1 kilowatts. If we had 1 megawatts, which equals to 1 million watts, then we can just write using the prefixes for mega. Yes, 1 megawatts. Here we have one example how we can convert horsepower into the power of the units of power in the English system, or how we can convert horsepower into watts, which are units in the SI system of power. And if we want to convert, for example, 300 feet pounds force per second to horsepower, then just we need to use this conversion factor. And the way we write the conversion factor depends on the units we don't want. Because we don't want this unit, the only way this can cancel out, it will write the conversion factor in this way. And in this case, we multiply 300 times 1, then we divide by 550, and we will have the units in the result in horsepower. Now, if we want to convert 0.545 horsepower to watts, then we need to use the second conversion factor. And the way we write the conversion factor is in the way the unit, we don't want cancel out, and we don't want horsepower, and one on top, one on bottom, then the cancel out, and we multiply 0.545 times 746, and we will have 46 watts. Then we can say now 300 pounds force per second equals to 0.545 horsepower equals to 406 watts. And just remember, and this force per second in your book you will find like that, okay? But the right way, you know, this pounds correspond to really pounds force, okay? Then I don't want you to get confused with that, and these are the same as pound force, okay? This is not units of mass, it's units of force in your book. Then let's now try one more example. In this case, we had an electric lift, and this electric lift can raise a 5,000 kilogram mass a distance of 10 meters in 5 seconds. Then what is the power of the lift? Then now we want to try to identify the variables, what information we know, and what we need to find. And in this case, we had lift, and this can lift an object of 500.0 kilograms. A time distance equals to 10.0 meters, and the time is 5.0 seconds. Then we want to know what is the power. And in this case, we can see we had meters, we had kilograms, we had seconds, and everything is in SI system. There's no problem with the units. Then now let's see what we know and with what we had to calculate, what we need to find it. We know the mass, we know the time, we know the distance, and we need to calculate the power. The power is work divided by the distance. And we need to calculate the work, because we know the time, but we need to find the work. But we know the work equals to force multiplied by the distance. Then do we know the force? We don't know the force, but we know the force that the electric lift needs to apply is the gravity force. It's the only way this can move the object. Then the force equals to the gravity force. Then the force in this case will be mass times G. And what we can do is we can calculate the force, then we will calculate the work, and finally we can calculate the power. Then let's first start with the force. Force is mass times G, and the force equals to 9.8 meters per second squared. And this force will be 4,900 newtons, because we had kilograms, meters per second squared. This corresponds to newtons. This is kilograms, if I can write, this is kilograms meters per second squared. This corresponds to newtons. And now we know the force, then we can calculate the work. Yes, we're done with the force. Now let's calculate the work. Work equal to force multiplied by the distance. Then we can see the force is applying in this direction and the distance or the object is moving in this direction. And they are parallel, then no problem, we can calculate the work. Then the work equal to force, which is 4,900 newtons multiplied by the distance, but the distance is 10 meters, 10 meters. And the work, 1, 2, 3. Newtons times meters equals to joules. As newtons times meter equals to joules, which are the units for work. And we calculate the force. Now we calculate the work. And finally, we will calculate the power. Then the power, work, divide by the and the power in this case will be 9,800 joules per second, correspond to watts. And we can write in this way the answer. You can write in scientific notation 1, 2, 3, 9.8. We can 2 significant digits. Yes, we have here 2. And 10 to the power 3 watts. Or you can write this one like 9.8 kilowatts. And this is 3 different ways you can write the answer, and all are correct. Yes, all are correct. And this is 3 different ways in which we can write the answer. I want to solve the problem not in different ways. It's just in the way you write the equations is different. Is first you complete the equation and then you just replace the values. Then I will solve the problem in both ways, because there are some students that they prefer to do in this way because they can see the units easily. And first is like steps. First calculate the work, then the force, and finally the power. But there is this way. There are some students that prefer this way. Then I will solve also in this way. In the other way the problem. Then we had power equals, let me see if I can write better, power work divided by the time. But in this case we can define the power, the work is force multiplied by the distance. But also we can define the force. The force is mass times g value. As the mass of the object is moving times g t. And we can calculate the power using also this equation. Divided by the time. Yes, it's basically the same, but just you are putting everything in. You put all in one equation. But there are some students that they get confused when they are doing that, and this is I am doing both ways. And now we know the mass, we know the g value, we know the distance, and we know the time. Then we can calculate the power. Then mass is 500 kilograms, g value 9.8, distance will be 10.0 meters, divided by 5.0 seconds. And if we multiply these numbers together, we will get the same thing we have got here. joules divided by 5.0 seconds. And then finally we will have 9,800. I will write here something. Let me, units, I want just, you see we had kilograms meter square over second square divided by 5.0. And we say this is joules, yes? And here you have to be careful with the units in this case. Then we can, in this case we have, and this corresponds to joules divided by, let me write here, the power will be 9,000. Then we say we can write this one. We can write this one in different, all this way. Then it's up to you how it's easier for you to solve the problem. You can solve in this way, or you can solve in this way. Right here, this is way, first way, the second way to solve the problem. And let's now try to solve the last problem. And in this example, we want to know how many seconds will take a 10 horsepower motor to lift a 2000 elevator a distance of 20 feet. And in this case, we had an elevator, and there is a motor that can lift this elevator. Feet. And the motor that lifts this elevator has a 10.0 horsepower, can develop 10 horsepower, and in this case we had 2,000 pounds. And here is, we have to be careful, because when this is in the book they say 2,000 pounds, this refers to 2,000 pounds force, and really is a force, no mass. Then in this case they are giving directly the weight of the elevator, and this is the force, is the weight of the elevator, yes, but is in English system, yes, is the. And again, in your book, when they say pounds, this corresponds to pounds force. And we know the distance, the elevator is moved, is 20 feet. And we want to know how many seconds will take to the motor move the elevator 20 feet. And we need to calculate the time. And the first thing we want to see if the units are consistent. And we are for force and for distance, we had the English units, but what happened for power, we had a different unit. And we need to convert everything in the same system of units. Then we need to convert, in this case, horsepower into units of power in the English system. Then let's do this part first. Then let's convert 10 horsepower into feet. Remember, this is pound force over second. And to do that, we need to multiply by, we need to use this conversion factor. Yes. And let's right here, will be 10.0 horsepower. Now you have to be careful how we need to write the conversion factor, then 1 horsepower on bottom and 550 on top. It will be pounds force per second. And in this way, this horsepower cancel out with this horsepower. If we multiply these numbers together, we have 5,500 per second. And now we know this one is 500. And now we have everything in the same system of Unix. Then now what we need to do is we need to calculate the time. And let's see what we need to do. And we know the power equals to work, and we know the power. We need to calculate the time. Do we know the work? And we know the force but not the work. Yes, then we need to calculate the work first. Work is force multiplied by the distance, then work equal to force. The force is 2,000 pounds. For multiplied by the distance, which is 20 feet. Then the work will be 1, 2, 3, 4. This is 40,000. And remember, this is the way it is in the book, is feet multiplied by pounds force. This is the units for work in the English system. Then we calculate now the work. Then we know the work, we know the power. Now we can calculate the time. And we had and we can cross multiplying, and then we will have power multiplied by t, and we divide by the power. And we need time equals to work divided by the power. And work is 40,000 feet divided by the power, but the power is 5,500 feet second. Then now we need to divide. Yes, we need to divide, and the time will be 7. And the time will be 7.27. You see this cancel out, and we had finally in seconds the time. And in the second part, we need to calculate this is the part 8. We need to calculate the average time. And we know the average velocity equals to the distance divided by the time. And we know the distance is 20 feet divided by the time, but the time is 7.27 seconds. And in this case, the velocity equals to 2. We divide this 75 feet per second. And this is the answer. Then this is all I had to discuss for today.